In this problem, I want to write symbolic statements for each of the circuits and then use a truth table to compare the two. So let's take a look at the first circuit, and here we see that this is a parallel circuit because we can go up through M and get to the light bulb, or we could go down through N. And since that is an OR statement, that's going to be M or N. Next, we have a series circuit, and so we're going through both of these to get to the light bulb. So we have negation of M, and we have negation of N. Notice that the notation changes a little for negation on that. We put a line over the variable when we're drawing the circuit, but when we are writing out the logic statement, we use our regular negation symbol. So now I'm ready to make a truth table for both of these. And I have for M, that could be true or false. We have two variables, so I'll have 4 rows. And N can also be true or false, and we alternate like that. The first circuit is M or N. So this is the result for the first one. And with OR, the only way for an OR statement to be false is if both M and N are both false. So this is going to be true, 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 false. And then we'll construct the truth table for the second circuit. So I need a negation of M, a negation of N, and then a negation of M and negation N. So negation, we're going to do the opposite of M, so that's going to be false, false, false. Oops, not false, false, true, true. And then N will be false, true, false, true. And when we use and, we know that the only way for that to be true is if both the terms are true. So we have false, 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 and then true. So this is our result for the second circuit, and we can see that that is different from what we got for the first circuit, so they would be not equivalent, would be the answer for that. Now for these circuits, we have our first circuit, and we want a symbolic statement for that, so that's going to be P and not Q for the first option. Or you can go through the bottom, and that's not R. And then we have to go through P. So there's and P. So that's the first one. The second one, we can go through not Q or not R. But we have to go through not P. So that's how I form those two statements, and now I can use a truth table to determine if the circuits are equivalent. Okay, so now I have my truth table somewhat set up. Let me put in my variables. Okay, so now I've got my variables set up, And I'm going to look at my statements that I have here. I have a negation of Q, and I'll do that. That will be the negation of column 2. So that's going to be false, false, true, true, false, false, and true, true. And I'm going to keep track of my columns here. And this was the negation of 2. Okay. And then I have negation of R. And so we're negating column 3. And we're making column 5 out of that. So now these truth values are going to alternate. False, true, false, true, false, true, false, true. And now I'm ready to do this expression within parentheses. I could have done that before I did the not R, and it's really just up to you what you how you want to do that. So I have P, and not Q. So that's column 1 and column 4. And that's making column 6. So 1 and 4, I'm looking for 2 trues. I've got a true, true here and a true, true there as well. And let's see, everything else has some false in it. So the rest of them are all going to turn out to be false. Okay. And now we can combine that with the not R, and I just realized that I am missing one column here. So I'll fix that in a second. Okay. So let's see, we have the column we just did, column 6. And then we have negation of R, and that's column 5. And that's making column 7. Okay. So, or what I do for that is I look for 2 falses, and that's the only way for that to be false. So this is 5 and 6. So 2 falses. Here we've got a false here. This is going to be true. If there's any true in it at all for or, then the answer is true. Here we have false, true, false, and true. So that's what we're looking at for that. And now I'm ready to do the entire expression for number 1. So that's going to be P and not Q, or not R, and P. So that was the column we just did, column 7, and column 1. So I'm looking at the first and the last columns, and this is and. So the only way for it to be true is for them both to be true. So this is going to be true. This one was false. True, true, and true, true. These are both true. And then we have a false in the next 2 in at least one place. So that's going to be false. And then we have the last 2 are going to be false. So this is the truth table for this first statement. And I can't fit the second one in the same screen, so I'm going to go and make a second truth table, and then we'll just compare the results and see if this column matches up with the last column of the next statement. Okay, so now I'm ready to make my truth table for the second part, and I'll label my columns. And I just like to go in alphabetical order, so I'm going to negate column 1, and this will be not P, and then negation of column 2, and that'll be not Q, and negation of column 3, which is going to be column 6, will be not R. All right, so I just want to do the opposite of the P's, and that is a lot of false and then a bunch of true. And then same deal with negation of Q. We're going to have false, false, true, true, false, false, true, true. And finally, negation of R, we just alternate false, true, false, true, false, true, false, true. Okay. And now I am ready to do what's inside the parentheses here. So this is going to be negation Q or negation R. And that is column 5 or column 6. Or I know that false or false is false. Everything else is true. So we have a false, true, 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 false, true, true, true. Okay. Now we're ready to do the whole thing. And I have negation of Q or negation R and negation of P. So that's the column we just did, 7 and column 4. So just cover up the columns that you're not looking at currently. And this is an OR, so that means that true and true is true. Everything else is false. So I'm looking for mainly false here. If there's any false in it, it's going to be false. So that's true, and that is true. Is that right? Did I get those all lined up? That looks good. Okay, so now our previous statement was false, true, 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 and then the rest are all false. We can see that those don't match up, and so we would say they are not equivalent 20 years after we started this problem. It's very, very long, but that's how you would do that.